Okay, we are just going to do a quick video to review some things about rationalizing denominators, simplifying with rational exponents, things like that. So just going to be a quick review of the things that we've done, but just to help you to remember. So one of the things is in algebra, in order for a fraction to be simplified, one of the rules, the math rules, if you will, says you cannot have a radical in the denominator. Well, how do we get rid of it? We do what's called, oops, I meant to highlight that, rationalizing it. And how do we rationalize the denominator? It's pretty simple, really. If we have a square root in the denominator, that's no good. We can't have that. So what we need to do is whatever the square root is in the denominator, we are going to multiply the top and the bottom by that value. So we're going to multiply, in this case, we're going to multiply the top and the bottom by the square root of 3. Okay, what that does is when we multiply these together, so 4 times the square root of 3 is just 4 times the square root of 3. It is in no way any version of 12 or the square root of 12. The 4 is on the outside. Okay, oops, the 4 is on the outside. The 3 is underneath of the radical, and it needs to stay there. So the 4 stays on the outside, the 3 goes underneath. And then we have the square root of 3 times the square root of 3. Well, the multiplying, they are both under the radical, which means it's okay to multiply them together. So when we multiply the square root of 3 times the square root of 3, we get the square root of 9. Well, we know the square root of 9 is just 3. That's why we multiplied the top and the bottom by the square root of 3. So we'd have 4 times the square root of 3. Square root of 9 is just 3. Okay, and again, this 3 right here is under the radical. This 3 down here is not. They are not friends. They do not simplify each other out, and they do not cancel each other out. One's under a radical, one's not. Okay, so let's just take this idea and do it on a couple more examples. This one has a square root in the top and a square root in the bottom. Whatever is under the radical in the bottom, that is what we're going to multiply the top and the bottom by. So we're going to multiply by the square root of 2 on the top and the bottom. Now in this case, right, we've got both the 7 and the 2 are both under the radical, which means we can multiply them together to get the square root of 14. And again, the square root of 2 times the square root of 2 is the square root of 4. And the square root of 4 is just 2. Remember, this 14 is under the radical. This 2 is not. They are not friends. They do not simplify each other. That is no version of 7 whatsoever. It has to stay the square root of 14 over the square root of 2, or excuse me, the square root of 14 over 2. Okay, and then we just have a couple more examples here where you've got like a coefficient essentially. So you've got the 2, and then you also have a square root of 5. Okay, all we need to get rid of is the square root. So we are just going to multiply the top and the bottom. Again, it's a fraction as long as we do the same thing to the top and the bottom. Life is good. Okay, we've got 3 times the square root of 5. The 3 and the square root of 5 do not go together. 3 is outside, 5 is underneath. And then what we have here, the 2 times the square root of 5, keeping in mind, these are all being multiplied together. So we have 2 times the square root of 5 times the square root of 5 is the square root of 25. And the square root of 25 is just 5. So we'd have 2 times 5, which is 10. And we are going to leave it in that form. Again, that 5 and that 10 do not simplify each other. The 5 is under the radical, the 10 is not. Okay, and then we just have a couple of examples where you have to look at, if you notice in the numerator, you've got this plus sign here that we have to deal with. So we're going to talk about what to do if there's a binomial or two terms in the top. Okay, so you have 5 plus the square root of 6, 2 times the square root of 5. Again, we want to get rid of the square root of 5, so we are just going to multiply the top and the bottom by the square root of 5. Again, we have to do everything on the top and the bottom at the same. Okay, and this is just like if you had a problem where you were multiplying like 5 times x plus 2. We have to use that distributive property. In this case, since there's 2 terms in that numerator, we have to multiply both terms by the square root of 5. So what we're going to end up with is 5 times the square root of 5. That first 5 and the second 5, one's under the radical, one is not. So remember, this 5 is not under the radical, this 5 is, so they stay separate. And then we have the square root of 6 times the square root of 5. They're both under the radical, so if they're both under the radical, we can multiply them together and get the square root of 30. And then in the bottom, we have 2 times square root of 5 times the square root of 5 is the square root of 25. 2 times 5 is 10. And again, our answer is going to look kind of ugly like that, but there's nothing that we can do past that to simplify. 30 doesn't have any perfect squares that we can take out of it, so we're just going to have to leave it as it is. And we can't simplify the 5 and the 10 as it sits. We'd have to separate them into 2 separate fractions and stuff, but we're just going to leave it as one single fraction and leave it as it is. So one more quick example here. We've got square root of 2 in the denominator, so I need to multiply the square root of 2 on the top and on the bottom. And again, we need to make sure that we are distributing that square root of 2 on the top to both of them. Okay, so we would have 6 times the square root of 2 plus 4 times the square root of 10. That's going to be on the top. And then on the bottom, we would have 2 times the square root of 4, which is 2 times 2, which is going to be 4. If we want to leave it like that, we possibly can. Otherwise, it can be simplified if we break it apart into 2 separate pieces where we would have 6 times the square root of 2 over 4. We just took this side, plus 4 times the square root of 10 over 4. Okay, then we can simplify each of those fractions. 6 and 4, you can take a 2 out of each of those, so you'd have 3 times the square root of 2 over 2, and then 4 and 4 simplifies, so you just have plus the square root of 10. So that's another way that you can write it. So just something to think about. And that was one of the topics I believe that on the quiz I noticed that quite a few people were struggling with, so I thought I'd take a few minutes and review that. And the rest of this is just a review of some other things that I thought would be a good idea to remember. Okay, so this is going from radical to rational exponents, just going back and forth between the two. We can kind of read here. There are 2 different ways you can write radicals that are equivalent. One, as a radical, like you already know, that looks like this, like a radical is the square root of 2. The other is to write it with a rational exponent, which means a fraction exponent. The 2 expressions are equivalent, just written in 2 different ways, kind of like 1/2 and 0.5 are the same thing. They're just written 2 different ways. That's all that radical and rational exponent forms are. It's writing the same thing 2 different ways. So just a couple of things to remember. The square root of x and x to the 1/2 are the same thing. Just a reminder, in radical form, if there is no root there, it's going to be a square root, which is a 2. And if there's no exponent, we're always raised to the first power. So if you notice, the x and the x are here. And then we also have the 1, the first power goes in the top, and we have this root here goes in the denominator. And that same thing, we follow that same idea on all of these. We have, here's what's under the radical, that's our base. Then we have our power here is on the top, and our root is on the bottom. Okay, so again, just looking at it again, x, oops, daisies. I was going to do that in the same color, x, and then we've got our exponent on top and our root on the bottom. Okay, so if we're following that basic pattern when we do these, the one on the right is written as a rational exponent. If we want to rewrite it as a radical, this number right here stays exactly the same and goes underneath. Okay, this number right here is our power on the outside, and this number is our root here. Okay, so it would be the 5th power of x squared. Okay, same idea here. We're going to rewrite it as a radical. This guy stays exactly the same. This is our root, and this 1 is our power. Similarly, going in the opposite direction, z, or cube root of z squared. Okay, our z is our base, that's going to stay the same. The 2 is our numerator, the 3 is our denominator. And not to forget, if there's no power, there is a 1, so we would have x as our base, 1 is our power, and 4 is our denominator. So that's just a quick review in case you forgot how to go between the two of them. Let's look at a couple of more things. Okay, this, I know that some of you probably just used your calculator to calculate this on the quiz because there was some people that did not follow the directions and rewrite it as a radical before they evaluated. These should not require a calculator. Any of them that we say to do without a calculator, you should be able to do just using the roots that we know. So the 25 to the 3/2 power, right? So now we're going to write it as a square root because this is our denominator is our root that we're going to take. So we're going to take the square root of 25, and we are going to take it to the 3rd power. We know the square root of 25 is 5. To the 3rd power is just 125. Okay, same thing. This one we've got 27 to the 2/3 power. Here's our 27. We're going to take the 3rd root, or the cube root, and we are going to square it. Notice we know that, we should anyway. The cube root of 27 is 3. We're going to square it. 3 squared is not 6. 3 squared is 9. And then the last one, just to make sure we know how to do it with fractions, we are going to, basically if you have a fraction raised to a fraction power, the way that I think about it is you take that 3/2 and you basically are going to take the 3/2 power of both the top and the bottom. So what that means is in the numerator, we are going to take the square root of 25 to the 3rd power, and we are going to take the square root of 4 also to the 3rd power. Notice the numbers that are under the radical are squares that we know, so we would have 5 to the 3rd power and 2 to the 3rd power. 5 to the 3rd we should know is 125, and 2 to the 3rd is not 6. 2 to the 3rd is 8. Okay, so let's just kind of keep going here a little bit. We got one more idea I just wanted to take a quick minute to make sure we understood how to do, because there seemed to be misconceptions with some of the students when I was grading the quizzes. And that's just simplifying radicals, okay? All this video is it's really just going back through the stuff that you've learned. We've had a nice long Thanksgiving break, so we're just going to review some of the stuff that we've already learned, just reviewing it for us. So we've got the square root of 36, x to the 5th, y to the 3rd, z to the 4th, remembering that if there isn't anything, there's a 2 there, okay? So the way I always like to do it is I give myself my square root, and I take each piece and I take the square root of each part. So what that means for me is that I'm going to take my coefficient, which is 36. 36 is a perfect square, which means when I take the square root of 36, that is going to go on the outside. The square root of 36, I can evaluate. What I can evaluate goes on the outside. So I'm going to put my 6 on the outside. Okay, so I've done that part. Next, I'm going to look at my x to the 5th. Okay, easiest way to simplify with these variables in there is to say how many groups of 2 can I take out of 5 and with how many left over? Well, 2 goes into 5 2 times, which means I'm going to take 2 groups of x's out. That means I'm going to take x squared out. Okay, and that means if I take 2 groups out, there is 1 left over. So 1x to the 1st power stays underneath of our radical. Then we do the same thing with our y. Okay, so let's look at y. How many groups of 2 can we take out of 3? So 2 goes into 3. 2 goes into 3 one time. So we're going to have 1 group of y's that come out. And we're going to have 1 left over that stays underneath. Okay, notice when we do the same thing with our z, z goes into 4 exactly 2 times, which means we can take 2 groups out, and there's none left over, so there's not going to be any z's left over in here. Okay, so let's just look real quick at a couple more examples, right? It's a cube root. It's going to be our answer. What lives outside of the cube root? What stays underneath? The cube root of 8. We know 8 is a perfect cube. The cube root of 8 is 2. that when we can evaluate it out, it stays on the outside. And then with x, how many groups of 3 can I take out? Well, 3 goes into 9 3 times, so I'm going to take 3 groups out. It goes exactly 3 times into 9, which means we're not going to have any x's left over underneath. And then my y goes into 7 2 times, so I'm going to have y squared because it's going to go in 2 times, and there'll be 1 left over, so I'm going to have y to the first left over underneath. And then the last thing, we got square root of a fraction, okay? Just to remember how to do that, we are going to basically take the square root of the top, and we're going to take the square root of the bottom. We're just taking that square root and splitting it apart. And we're going to do the exact same thing. The square root of 9 is just 3. And remember that the square root means there's a 2 there. How many groups of 2 can I take out of 8? 2 goes into 8 4 times, so we're going to have x to the 4th. There's no x's left over in the top. And then in our denominator, y to the 10th. How many groups of 2 can we take out? 2 goes into 10 5 times, so we're going to have y to the 5th power. The x and the y, it's different bases. We can't do anything with our exponent rules there. The 3 is the coefficient, so it's going to have to stay as well. So that's just a couple of examples with simplifying radicals. Your homework today is going to be to finish up. There's exponent extra practice worksheet. This is going to be in Schoology. So please make sure that you complete it and submit it. Okay, so make sure that you complete this. It is, let's see, there's 8 questions on the first page, and then there are another 8 questions on the second page. So make sure that that gets completed and submitted in class today. You will not have class time to finish it up tomorrow. This is a homework assignment that needs to be done in class today. Thank you much. Good luck.